Good morning, my name is Herminia Puerto. I will communicate the work orchard level assessment of irrigation performance and water productivity of an irrigation community in eastern Spain. Irrigation in Spain has two distinct periods. The second half of the 20th century, when big irrigation districts were developed, and the time of irrigation schemes modernization from 1996 to 2017, when more than half of the irrigated area in Spain was modernized to pressurized networks, mainly for drip irrigation systems. Having pressurized networks that allow for a high level of irrigation control, it is the time to ask if a management approach is needed to obtain the best result of these infrastructures. The assumption we made was that the performance of an irrigation network depends on the performance of the individual irrigators. This work is a result of the Go in the Water project, in which we used performance indicators and benchmarking to improve water management with a participatory approach. The partners of the project were one agricultural engineering consulting firm, one irrigation community of the Valencia province, the Valencian Federation of Agricultural Cooperatives, and two universities. This project was funded by the Spanish Plan for Rural Development. A performance indicator is a measurable value that shows how effectively an irrigator is achieving its farming objectives. We defined 6 indicators related to supply, productivity, economic output, and environment. First, the relative water supply, defined as the non-dimensional ratio between total annual volume of water supplied to the crop, that is irrigation plus effective rainfall, and the total annual volume of crop water demand, that is the calculated crop evapotranspiration. The relative irrigation supply, calculated as the total annual volume of irrigation water applied to the crop and the total annual volume of crop irrigation demand, that is, crop evapotranspiration minus effective rainfall. The crop yield gap, as the crop yield actually obtained, and the crop attainable yield in local conditions, in percentage. The overall water productivity, as the ratio between total annual mass of crop yield and the total annual volume of irrigation water applied to the crop, in kilograms per cubic meter. The output per unit irrigation water as the ratio between total annual volume of crop production and the total annual volume of irrigation water applied to the crop. Percentage of nitrogen as the ratio between the nitrogen fertilizer units supplied with irrigation water and the nitrogen units required by the crop. The data values of individual plots were obtained from the irrigation community census. They were the crop and variety, the planting date, the distance between rows and between trees in the rows, the plot surface area, and the total annual irrigation measured at the water meter. The corresponding yield data were given by the commercialization cooperative, and we made soil textural analysis at representative plots. Climate data were obtained from a nearby agrometeorological station belonging to the Agroclimatic Information System for Irrigation of the Ministry of Agriculture. Crop coefficients were obtained from the Valencian Agricultural Research Institute. Crop evapotranspiration and effective precipitation were calculated using the CropWatt program of FAO. 104 plots were considered in the study, 55 of persimmon orchard and 46 peach orchards. Our study considers 4 years, from 2017 to 2020. These graphs show the trends along time in months in the x-axis of global radiation in yellow continuous lines, the trends in temperature in red lines with full circles in the left y-axis. The blue bars show total precipitation of the right y-axis. Radiation and temperature were very similar for all years, as well as the total rainfall. If we take only the rainfall during the growing season from March to end October, the 2019 season had almost 200 millimeters higher values than the rest, and this rainfall was concentrated in April. These graphs show the yield in kilograms per hectare in the y-axis versus the relative irrigation supply in the x-axis. Each dot corresponds to the average of plots in the three categories, labeled as sapling, young, and adult for each different year. On the left graph, we see persimmon, and on the right, the peach orchards. In both cases, relative irrigation supply values are lower than 1, indicating a general deficit irrigation. This trend is more evident for persimmon. Adult trees tend to receive much less irrigation than required, and as indicated by RIS values lower than a unit. Saplings tend to receive some more irrigation, showing RIS values between 0.6 and 1, since growth at these stages is very sensitive to water stress. The positive relationship of yield with relative irrigation supply that could be expected is masked in this graph. As in the previous slide, these graphs show the yield in kilograms per hectare in the y-axis versus the planting framework in square meters per tree in the x-axis. Each dot corresponds to the average of plot in the three categories and the 4 years. For both crops, there is a tendency of newer orchards for higher planting densities. That is, lower values of planting framework as compared to older adult plantations. For persimmon, adult orchards had the highest yield values despite young ones had higher planting densities. For peach, young orchards had higher or equal yields than adult orchards. In this case, higher planting densities compensate the lower yields of younger trees. This table shows the averages of the overall water productivity and the percentage of nitrogen fertilization obtained with irrigation water. In our case, knowing the percentage of nitrogen received by the crop with irrigation water was important, since the water of the irrigation community is regenerated municipal wastewater, except for year 2019, in which irrigation water was fresh water from the river overflow. We see in the table that overall water productivity are high and comparable to those obtained for citrus in nearby irrigation areas. Output per unit irrigation water averages that are not shown follow the same trend of overall water productivity, being fruit prices the proportionality factor. As for the nitrogen, in no cases the percentage of nitrogen received by irrigation water exceeds the crop nitrogen requirements, so that no environmental pollution effects are to be expected. As conclusions, we have that the general trend of relative irrigation supply values indicate that deficit irrigation is a shared feature of this irrigation community. This is a common characteristic of irrigation communities in Spain. There is also a tendency to higher planting densities in newly established orchards, and young trees tend to have higher relative irrigation supply values. Overall, water productivity values are similar to those of citrus in similar conditions, and these are initial results. The project Go No Water has implemented an irrigation assessment software in the current season, so that more work is required to test the effects of this software in the irrigation practice of the irrigation community. For more information, you can visit the project website goinnowater.org, and thank you so much for your attention.